I'm here at home, which is totally fine. I've got all my stuff here set up. I think for the most part ready to go. What I want to do is see if there's anybody that has any general just short questions that we want to go through. Since it's just the four of us, we can keep this pretty informal. But if anybody has anything they want to go through, anything that's a little fuzzy, what have you, you name it, floor is yours. So I'll turn it over to you. Will there be more than one deflection problem? That's a good question. There will be. So I've completed the exam, and this is what I'll tell you. There are 4 conceptual questions, 3 computational. I will tell you about the computational. One's a deflection, and one's an influence line. The other one, it's either a deflection or an influence line. I'm going to leave it at that. Let me say one thing, though, about this, okay? And I want to be crystal clear about this aspect. This is what I will tell you. I think for most of the problems, I've given you a fair amount of stuff to go off of. And I'm going to tell you that by referencing some exams that I've given in the past. And just bear with me and you'll see what I mean. Okay, so let me think of some examples or some problems I've done in the past. So in the past, let's say I do a beam deflection problem. Well, one of the ways that I've made the exam a little faster for you is I've given you some of the moment functions, because I don't want this to be a time crunch. Okay, the first piece of advice I would give you is to read the exam. Okay, to read the exam, because a lot of the data is given to you. And I'm doing that to try and make the exam faster. Okay. If there is a truss problem on the exam, it will be a very small truss. It will not be a truss that has 12 members in it. It will be very small. We're talking a truss that has 5 members or 3 members or something like that. Very tiny. Nothing large.
Well, Harrison beat me to my first question, but my second one is, could you go over a truss problem?
Sure. I can, yeah. Give me 1 second. What I'm doing here is I'm unpairing my Bluetooth here. What'll probably end up having to happen is I'm here at home and I'm using my my Microsoft Surface. I'll have to disconnect the hard drives here for a sec and then pull up the problem. But the short answer is yes, absolutely. I'm more than happy to go through a truss problem. That's not an issue. But I want to make sure that if I do that, that's going to take a little bit of time. So I don't want to spend the full 50 minutes on that unless that's what everybody wants me to do, and then I'll be happy to. So let me know where everybody else sits, because we've got Jeffrey, we've got Courtney on here. So whatever your thoughts are, we can go through anything. While you're okay, all right. Does that sound good to you, Mr. Atkins? You're here for the ride. Okay. All right.
Yeah, I am a little bit.
Okay. Give me 1 sec. I've got to rearrange my tech setup a bit, and we'll get this rocking and rolling. Give me 1 sec, okay? All right, can everybody hear me?
Yeah.
Okay, let's see if I can reduce the echo a bit. All right, let's see.
Hey, Dr. Michelson.
Yes.
I'm just curious about what was the decision that the university decided upon for the mental health day?
Basically, that they're letting each of the faculty members sort of make their own decision. And so what I did is just we did the exam review on Wednesday, and I made today optional. But some faculty can do it, some faculty wouldn't. And I'll tell you, if we had known about it probably a little bit more in advance, probably everybody would have it would because it was such short notice. All right. Okay. Audio still coming through clearly because I changed my settings a bit.
Yeah, sounds good.
Okay. All right. Let me go to my notebook here, and let's see. Let's just add a blank page. Okay. So first thing I'm going to do is so that you all see what's going on here. Let me share my screen. Okay, so I have a blank sheet here. Let me get my structures book and let me see if I can find like a good example that we can all work on together. That's manageable within the time frame. Okay, so chapter 7. Let's see. Okay, all right. I've got. Let's see. Hold on for 1 sec. Give me 1 sec. I saw something in chat, but I was getting my book. What is in chat? My cousin is a psych major, and that's kind of funny. I don't know why I find that funny, but I do. Okay. Let's see. Let's do problem 7.6. Yeah, let's do 7.6. Okay. So this is textbook problem 7.6, and we have a truss that looks like this. Here, let me make that. Let me move that down here. We have a truss that looks like this, and like this, like that, like that, that, and that. Okay, that's the truss. Maybe I can make that a little better. There we go. That's a little better. Okay, so here's the truss. Let me add some data to this. So we know that this is 25 kips. We know that this is 25 kips. And we know that this is a hinge or pin support. This is a roller. Let's see. Let's label the joints. This is A. This is B. This is C. This is E. And this is D. Okay. In terms of dimensions, this is 15 feet. And each of these are 20 feet. And the question that we're trying to determine. I need to put the areas on here. So this is 4 square inches. So they're all 4. Or hold on, no, that's not true. Okay, so this is 4. This is 4. This is 4. But maybe I'll use a different color so that's a little easier to see. This is 3. This is 3. this is 3. You know, there's this like standard galaxy pen. I'm going to change that. I'm going to make it like purple or something. There we go. Okay, so there's the truss, and what we're trying to find is we're trying to find the deflection at joint C, and we're trying to find the vertical deflection, right? So that's what we're trying to figure out. And for this truss, we know that E is 29,000 KSI. Okay. All right. So does anybody have any questions, like understanding the problem, making sure that we're clear on what we need to do? Okay. And if you have any questions, just let me know. Okay. So I'm going to fly on autopilot. I'm going to shut my book here and let's just sort of jump right into it. Okay. And if you got any questions, let me know. I'm here at home, so the point is, it might be easier if during the problem, if you have any questions, it might be easier to turn your mic on, because it might that might be a little more straightforward. Before I begin the problem, one of the things I want to mention is the slope ratio for both of the diagonals is like 20 to 15, but that's the same thing as a 3 to 4. Okay, because if you divide both of those by 5, you're going to get 3 to 4. So all of the diagonals are on a 3, 4, 5, which is going to make the math a little bit easier to do. Let's see if we can determine some support reactions. So if I sum forces in the y direction, okay, I'm going to get that if I got 25 down and 25 down, that has to be 50 going up, right? The vertical reaction. So this is going to dy is 50 going up, right? If I'm going too fast, you let me know, okay? As for the horizontal reactions, I think what's going to happen is if you look at all of the forces and that are applied, the ones at D, the ones at B, the ones at C, they're needing to sort of rotate the truss like that. So the reactions at A and D have to rotate the truss the other way. They have to rotate it like that. I think this reaction is going to go like that, and this reaction is going to go like this. Of course, you know, that's just an assumption. You can always sum the moments and do that. Let's go ahead and do that now. So I'm going to sum moments at D. Right? So if I sum moments at D, I've got 25 kips times 20 feet. And then I've got 25 kips times 40 feet, right? That's the one at B and the one at C. And that has to be resisted by AX times a arm of 15 feet, right? So let me get my calculator. I know I'm going to need that. All right, so 25 times 20, that's 1,000. 25 times 40, 2,000. So 3,000 foot kips is AX times 15 feet. So AX is that 20 or sorry 200? Did I do something? What did I do? I feel like I did something. Maybe maybe it is 200. That seems high, but yeah. Hold on. Let's see. 25 times 20. Oh no. I know what I did wrong. I'm doing my mental math is suffering. This is 500. This is 1,000. So that's 1,500. And 1,500 divided by 15. That's 100. That sounds better. Okay. So if AX is 100 kips to the right, then this is 100 kips to the left. And those are my reactions. Okay, that looks a little better. Okay, any questions? There, I thought, did I hear something? Okay. All right. Let me show you a real quick way of doing the truss analysis, and this is the nice thing about paper. You can do this however you want. So what I'm going to do is I'm going to actually sort of draw the truss in this really like sort of expanded fashion, right? So there's the truss, right? And so let's sort of draw these little stubs for the truss members, right? And then, yeah, so that one's going to go like this. That one's going to go like that. That one, yeah, it's going to go like this. And this one's going to go like that. Okay. And what I'll do is I'll sort of like do that. Okay. Next thing, let's put the loads. So this one had 25 kips. This one has 25 kips. This one has 50 kips. And then the reactions were, okay, yeah, so this one, 100 kips. This one, 100 kips. Okay. And keep in mind, and I'll put this over here, all the diagonals are at a 3:4 slope ratio. Okay. So watch this. Okay. Let's also label the joints, right? So this is how did it label? It was A, B, C, D. Okay, so this is A, this is B, this is C, and this is D, and that's E. Okay, so what I did is I basically just redrew the truss and I exploded it a little bit. And the nice thing about doing it this way is it allows you to do all of the method of joints analyses like all at once, and hopefully it can reduce the number of errors that you do. There's nothing magical about what I'm doing here. It's not like a big secret, but you'll see how I'm going about this. So which joint do you want to do first? Well, first off, there's only two joints that we can start with. We can either start at joint D or joint C because all of the others have two unknowns. So which one do you want to start with? Somebody help me out. Somebody pick one. C. Okay, we'll start. Who? I'll do D. I'll do D. Okay. So check this out. All right. So look at joint D. So we're looking at this one right here. I got 50 up. That has to be 50 going down. I got 100 to the left. That has to be 100 to the right. There we go. That joint's done. All right. Now look at this. This is what I'm going to do immediately after I finish the joint. Okay. Before I even try and solve anything else. Look at this joint right here. Look at joint E. Okay. See how I have 100 to the right? That has to be 100 to the left. Just do that now. This has to be 50 down. That has to be 50 up. Like just immediately write those. Like, when you go to the other side of the joint, it's an equal and opposite direction. So just go ahead and put those there now. All right. Now let's go back to joint C. All right. So we've got that, that, and that. Right. Two horizontals, one vertical. 25 down. That's got to be 25 up. Right. Okay. Now if that's 25 up, first off, we know that's going to go that way because it's in tension. And how do we get this? We take 25 and we multiply it by a fraction. The fraction's going to be 4/3, right? The larger number is on the horizontal. And so 25 times 4/3 is 33.33. Okay, so I can automatically do that now, right? And if that's 33.33 to the left, this is 33.33 to the right. Okay, now once you're finished with the joint, immediately go to the one over 33.33. Right? Go to the next one, do the same thing. This is over 33.33. This is down 25. Okay, just immediately transpose those. Then what I might do is, like, I'm lazy. I like to go to the easy problem. So let's do joint B. Okay, I got 25 down, 25 up, 33.33 to the right, or to the left, 33.33 to the right. Boom, that joint's done. Okay. Next, what's the next joint? We gotta look at point A. But remember, immediately go in and transpose. Sorry, record, not transpose. Record the response from the adjacent joint. I've got matrix analysis in my head. You'll see what I mean with transpose. Okay. What do I have here? Hold on. Do I have a numerical issue here? Let me check. I feel like I'm missing something. Or I did something wrong. Let me see. Hold on. Let's see. Give me 1 second. This is what happens when you do it on the fly. So 25. Something isn't right here. I'm missing something. Because this is going to be 33. Oh, no. Now I see what's going on. No, I'm right. Sorry. I'm right. Ignore that. My coffee hasn't kicked in. Okay. So the nice thing about this joint here is that you can treat each value independently and you'll get the right answer. So watch this. I got 50 up. That's got to be 50 going down. Now, what was going on was I was forgetting that reaction. If I have 100 to the right and I have 33.33 to the left, this has to be 66.67 to the left. Now check out what's going on here. If you take 66.67 and divide it by 50, you get 4/3, right? So 66.67 over 50 is equal to 4/3. So by independently doing those joints, you find that the slope ratio is already matched. And here's something else that's really cool. And we didn't do this, I think, when we did this in class, but check this out. Let's look at joint E. You actually don't need to look at joint E because the truss is already figured out. But if you look at joint E, what do we have? We have 50 down, so that's 50 going up. We have 66.67 to the left, so 66.67 to the right. If you look at joint E is already meeting equilibrium. At least it should, because, hold on, yep, we got that right there. Look what we have. Look at the verticals. We got 50 up, we got 50 down. We got 100 to the left, we got 100 to the right. Everything is already solved with joint E. It's already figured out. So we've, in one fell swoop, the truss is already solved, right? Already figured out. And so what I can do is I can sort of go down here and say, what's my truss? What's my answer? Sorry. I can go in and just start writing down all of my forces, right? So what are my forces? Okay, so this one, let's see, let's use purple here. So this one is 33.33 kips in, what is that, compression. This one, or I'll do the diagonals last, but this one is 25 kips in tension. This one is 50 kips in tension. This one is, what is that, 100 kips in tension. This one is 33.33 kips in compression. And as for the diagonals, just use the Pythagorean theorem, right? So I've got 25 squared plus 33.33 squared, and then the square root. So this is 41.67 kips in tension. And then this diagonal is going to be basically just double that. And so 83.33 kips in compression. Okay. And so this is the real analysis. Now, before we move on, let me just say one thing. I'm fully aware as we're doing this problem that this is a long problem. And so I'm not trying to set you up for super long problems on the exam. So don't get freaked out if you're like, oh God, he's only like halfway done with the problem. You know, we've been here for so long. Don't let that freak you out. Again, this is a really long problem that I just am sort of doing on the fly. Any questions before we move on and do the virtual analysis? So I can scroll down like here, if that helps. What happened there? Everybody still see the notebook? Yeah. Let me give you a minute. Okay. All right. So let's look at the virtual structure. So with the virtual structure, we've got the same truss. So virtual structure. So same truss. I think which way was that? Yeah, like that. Okay, so this one was going like this. This one's going like this. Right. Okay. And for this structure, what we're doing is, remember, we're defining the deflection at C in the Y direction. So first off, we need to place a 1.0 load at C, because remember, this was A, B, C, D, and E. And as for the direction, so the magnitude is 1. What about the direction? I don't know about you, but I kind of think that is going to be pointing downwards. Like if I look at the original structure, I think that point C is going to deflect downwards. So I'm going to put that load acting downwards. If I get a negative answer when I do my deflection, it doesn't mean I need to develop significant emotional distress. It just means that I, chose the incorrect direction. So if I have 1 down, that means that that's going to be 1 up. And if that's going to be 1 up, let's see what I got going on here. So this is 20 feet, 20 feet. Direction here, this is 15 feet, right? And so if I sum moments at D, what am I going to have? I'm going to have 1 times 40 equals the reaction times 15. So 40 over 15, I'm getting like, this is 8/3. And if I did that kind of fast, I'll do it formally. So sum moments at D. So if I sum moments at D, I'm going to have, 1 times 40. And so I'm going to have AX times 15 counteracting that. So 40 is AX times 15. And so AX is 8/3 acting that way. And so if that's 8/3, this is going to be 8/3 just acting in the other direction. Okay. Before I jump into the analysis, is there anything, or is there, let me look at it this way. Does anybody see any zero force members? That make our lives a little easier when we do the truss analysis.
Would it be BE?
You're exactly right. That's a zero force member because there's no vertical load on that joint. So because there's no vertical load on that joint, if I sum forces in the Y direction for that joint, I'm going to get 0 there. So just right off the bat, making my life a little easier, if possible, doing the analysis. Okay, so I'm going to pull the same trick. I'm going to do this, do whatever a little bit, do that, do that, do that, do that, do that. Draw my little stubs. And then I have this member going like this going like that going like that. Okay. All right, and let's see if I can knock out the truss analysis pretty quick. So that's 1, that's 1, and then this is 8/3, that 8/3, right? So let's see. I know that's going to be 1. I know that's going to be 8/3. I know that's going to be 1. I know that's going to be 8/3. Okay. I know that this member is 0. That member is 0. So go ahead and knock that out now. Okay. What about this diagonal down here on the bottom at C? Okay, I got vertical, horizontal, horizontal. Okay. I know that's 1, and that's going to be, because remember this diagonal is 3 to 4, so that's going to be 4/3. That's going to be 4/3. Immediately transpose it to the next joint. 4/3, and then that 1, that 4/3. Okay. All right. Keep going. Let's look at this middle joint here. That's 4/3. So if you notice, I'm kind of using a color scheme, like blue are my unknowns, and then green are the values that I know from previous joint analyses. So it sort of shows you the logic that I'm going through. All right, so 1 up, 1 down, 8/3, and then 4/3 makes that 4/3. Automatically comports to the slope ratio. And then if you look here, that's 1, that's 4/3. That final joint automatically meets equilibrium. So boom, the truss is solved. Now all I have to do is go in, write my answer. I'm still chuckling over Courtney's comment. That's kind of funny. All right. This is 4/3 in compression, right? This is 4/3 in compression. Let's see. This is, so these diagonals, if you have 1 and 4/3, I think if you chug that out, so 1 squared plus 4/3 squared, take the square root, it's 5/3. This is 5/3, and what is that? That's tension, and this is going to be 5/3 in compression. This is 1 in tension, and this is 8/3 in tension. Oh. Virtual analysis. Okay, let me take a sec and give everybody a chance to copy down what I've been doing and see if anybody has any questions. Because if you notice, we've got results from the real analysis and the results from the virtual analysis. Let's just take a sec and see if anybody has any questions. Which, by the way, this 7.6, I should have mentioned at the very beginning, this was in a different version of the book, so you might actually not have this truss, but that doesn't really matter. Okay, let me open up an Excel sheet. Give me 1 second. All right, any questions? I'm not hearing anything from chat, so I just want to make sure I'm still good, that I'm not rushing through all this.
Yeah, you're good.
Okay. All right. So let me stop the share real quick and share this Excel sheet. Actually, let me save it to the desktop so that I don't. Sometimes I found that when you're sharing stuff, that can be a little strange sometimes. Okay. So let me share content, share application. Okay. So here's the truss, and I need to do the method of virtual work. Now I could do this on the whiteboard, but I think it'll be a little faster to do it here in Excel. Let me zoom in a little bit so the text shows up a little bigger. Okay, so we need to set up a table. Okay, so we need to set up a table with the member, and we need 3 quantities for the members, right? We need the little f values, we need the big F values in kits, we need the lengths. Now remember, when you're doing truss deflections, everything needs to be of consistent units. So we need the truss lengths to be in inches. We need the E in square inches. And the reason we need those 5 values is because, remember, how do you compute truss deflections? You take the little f times the big F, big L divided by the EAs. So that's really the calculation that we need to do. So let's start off by just labeling the data that we know. So what are the truss members? We've got the horizontals. We've got member AB, BC, and we've got DE. So those are the 3 horizontal members. We've got the 2 vertical members, and maybe I'll stick this sort of over here. And we've got the 2 diagonals. We've got AE and we've got CE. Okay, so this truss had 7 members. Okay, so let's start off with the E values. We know that's 29,000 for every member. Okay, we know that. What about the areas? Okay, well, they're all 4 except for 3 of them. Let's see, AD, so the verticals, that one's 3, that one's 3, and then this one's 3. Everything else is 4. So those are those taken care of. Okay, now what about the lengths? Okay, this is probably something that's very easy to mess up on. So the 3 horizontals, the AB, the BC, and the DE, those are 20 feet long, but this has got to be in inches, so 20 times 12. Okay. For the verticals are 15 feet long, but that needs to be in inches, so 15 times 12. The diagonals, we can take the square root of 20 squared plus 15 squared, but again, it's got to be multiplied by 12 in inches. Okay. So this is our truss analysis. Okay, this is our method of virtual work setup. Everything needs to be in consistent units. So if you remember, we had a conversion factor for beams, like the deflection conversion factor was 1728 and whatnot, and for rotations it was like 144 times 180 over pi. For trusses, the conversion factor is 12 because you have to multiply the lengths by 12 to get inches. Okay, the only thing left to do is to plug in these values here. So I'm going to be kind of easy. I'm going to go back to this notebook that I wrote here. Okay. So, oh Lord, that's big. Okay, that's better. Okay, so these are the results of my real analysis. So in order to input these, we have to accept a sign convention. So I'm going to take tension to be positive. You could take compression to be positive if you want, just as long as you're consistent. If you're going to take compression to be positive, it's always got to be positive. If you're going to take tension to be positive, it's always got to be positive. So let's see. Maybe I'll cheat here and use this as my label since I didn't put the labels on there. Okay, so member AB, that was 33 1/3, and that's in compression. Right. Same thing with this member. DE was 100 in tension. That's positive. The two vertical members, AD, that's 50 and 25. The diagonals, we have this is 41 plus. Sorry, no, this one's 41 plus 2/3, and that's positive. This is 83 plus 1/3, and that's negative. Okay, so there's all my real analyses. Let me go to the virtual analyses. Move that sort of out of the way. Big. All right. There's the virtual analysis. I know it's probably kind of a mess with the organization, but I'm just sort of shooting from the hip here. So here's this, here's that. Okay. So member AB, that was negative 4/3. Anything with this one? This is 8/3. See the verticals. This is 1. That's 0. Let's see. This is negative 5/3 equals positive 5/3. And there's all the data. So all I have to do is say that times that times that divided by that times that. Bam. Repeat that. And sum it up. The deflection, because it's positive, is 1.4976 inches down. Boom. That's it. That is the answer. Okay. Let me give you all a sec. Take your time. Wait, did that? Oh, okay. Sorry. I thought for some reason that didn't show up. Okay. That is that example. Are there any questions? I didn't hear anything from the chat, and I hope I didn't go too fast.
You were all right, Dr. Michelson.
Good.
I need to log off here. I got another class meeting here at 11.
Okay. No worries. No worries. I can stay on for a sec if anybody has any questions. I mean, we're sort of meeting informally today.
Hey, Dr. Mike. So
Yeah.
on the exam, since this took you almost an entire class period, I figured that if you were to give us a trust problem, you would give us a good portion of the information, I figured.
You are correct,
like-
and also it would be a tinier truss if I were to give you one. You know what I mean?
Okay.
Like it would, this was like, here's the thing, like the process, the point I want to make with this problem is that the process is simple. It's not a hard process, you know. And you know, two other points to that. Number one, again, like if you understand the process, giving you a really big truss or a really tiny truss doesn't, it just makes me a jerk, and I'm really not trying to be a jerk. That's point one. But point two, I mean, one of the reasons also that this problem did take me a long time is that I was explaining it. You know what I mean? If I was just doing it, then I wouldn't be talking through it as I'm doing it. I wouldn't be stopping and, you know, saying, okay, does anybody have any questions and all that? I would just be chugging it out, you know. And same thing with you on an exam. Like, you wouldn't be stopping to talk to a class of 20 people and saying, okay, does everybody get this? You'd just be going along. So while it took me, you know, 50 minutes, I don't think even this exam would take you that long. Again, I'm not giving you one this big on the exam, so don't worry about that.
Okay, thank you.
No worries. Any other questions? I saw Mr. Enoch join us, Mr. Randolph, Mr. Ball. Looks good. Good deal. I don't know why I'm still chuckling over Courtney's comment. It's really funny. I don't know why I find it so funny. I mean, it's funny, but yeah.
I laughed at it as well, so you're not alone.
Oh, Lord. Any other questions? I know some of you have class, like we've already had 2 people leave because they have a class at 11. I mean, I'm more than willing to stick around for a little bit if you all want to go through some things, or we can call it. It's up to you.
Oh, I have a class, so I have to get off here.
Yeah. What about the others? Are you all good? Anything you want me to cover?
My brother is playing in the state semifinal soccer game right now, so I'm gonna go watch that game.
Reasonable.
It's being live streamed on Facebook.
Okay. All right. Mr. Ball. You don't have any questions? Okay. And I just to be Mr. Randolph, you're good. Okay. Well, I'm going to go ahead and stop the recording then. I wish everybody the best of luck on the exam, and we will see you all on Monday, or I guess on Wednesday. You know, I mean, I'll be around on Monday when you all are taking the exam, but we'll see you on Wednesday. That's all I got. Have a great weekend, everybody.